Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad HAIKAL HADZRAMI 1418F1003. I'm from Group J. Today I will talk about Lab 3, Lab 2, not Lab 3. Force mass acceleration. Firstly, objective: to understand the basic of the force, mass, and acceleration, Newton's second law. Number two, to know and use the equipment for experiment. And number three, to analyze the result for the measurement. And number four, to verify Newton's second law. For theory, Newton's second law of motion pertains to the behavior of the object of which all alternating force are not balanced. The second law states that the acceleration of an object is depend upon two variables: the net force acting upon the object and the mass of object. The acceleration of the an object depends directly upon the net force acting upon the object and inversely upon the mass of object. As the force acting upon an object is increased, as the mass of as, as the mass of an object is increased, the acceleration of the object is decreased. According the Newton's second law, acceleration is produced when force acting on a mass. The greater the mass of the object being acceleration, the greater the amount of the force need to acceleration the object. F equation ma, where F for force, m for mass, a for acceleration, and speed is the rate of the change in distance. In other words, it is how fast the distance changes in 1 unit of time. It is how fast the distance changes in 1 unit of time in mathematically displacement and be calculated from the following formula. Velocity v equal distance over time. Velocity is the rate of the change in displacement. It is how fast the displacement change in 1 unit of time. Acceleration is a change of velocity. Acceleration a equal velocity over time. Unit is ms square root 2 negative. And number three, equipment has a four: scale, stopwatch, meter ruler, and solid weight. The function of the scale to measure the weight of an item. The function of the stopwatch to handle the timepiece designed to measure the amount of the time that elapses between its activation and deactivation. And the 3-meter ruler function is device which is used to measure length of different object. And for solid weight function, the salt allow them to be placed on weight hanger with a lightweight platform attached to a dead with a hook at the top and can increase or decrease the load. Number 4, producer. Step 1, set up the apparatus and material as shown in figure 1 below. 2, recorded a value of the M1 and distance of the A1 consistent value, and 3 release a system from a 0 to n and record a time t when M1 drop down, and then repeat this procedure from different tests. And number 4, repeat this procedure with a different value of the M1, and 5, record the result at the table below.
Okay, this is the result for lab 2, and this is the table for test 1. Okay, the mass was given in gram, so I convert all this mass to kilogram. So all this will divide by 1000. So we got this 100 gram equal to 0.1 kilogram, 50 gram equal to 0.05 kilogram, 20 gram equal to 0.02 kilogram, 10 gram equal to 0.01 kilogram, 5 gram equal to 0.005 kilogram. And the time was given, time 1, time 2, time 3 for each mass. So this time average, the table, the column was blank, so I fill with my answer. So how I got my answer is T1 time 1 plus time 2 plus time 3. After that, the answer I divide by 3. So I got this answer. Every answer I use the same way. So first is 1.103, 1.109, 1.29, 1.20, and 1.47. And the velocity part was blank too, so I used to put my answer. So I use the formula is 0.2 is the height. I change to meter, 0.20 cm equal to 0.2 meter. So the how to get the velocity is the height divide by time average. So I use the same way to all of this, and we got all the answer. First answer is 0.18, 0.17, 0.16, 0.17, and 0.14. Then the acceleration is this answer blank too, so I write my answer, and the formula is the answer of velocity divided by the time. So this is the answer: 0.16, 0.14, 0.12, 0.14, and 0.1. After the test, I make one graph to show the result. Okay, this is table 2 or table for test 2. Okay, same like table 1. They gave the mass and we change to the kilogram, and yeah, divide by 1000. So the time 1, time 2, time 3 was given. So the answer for time average is the same, plus all that and divide by 3. So we got the answer for time average, and the velocity is same. The formula we use is 0.3 from the height, 30 cm up there. So we change to meter, so we get 0.3, and the formula is height divided by time. So we got the answer for all the velocity, and the acceleration is the same too. We use the answer from velocity divided by time, and we got the answer. So mass that we change from gram to kilogram is 0.1 kilogram, 0.05, 0.02, 0.01, and 0.005. and the time average and that we got after we plus all that and divided by 3 is 1.05 for the first column for the first row, and 0.97 for the second row, 0.83 for the third row, 1.11 is for the fourth row, and 1.28 for the fifth row. And the answer for the velocity that you can see, 0.29 for the first, 0.31 for the second, 0.36 for the third, 0.27 for the fourth, and the 0.23 for the last one, the fifth. And the acceleration is, we got the answer for the first 0.28, 0.32 for the second, 0.43 for the third, and the fourth is 0.24, and the last one is 0.18. So that the answer for table or result 2 for the test 2. Okay, 7 is discussion. Okay, based on the test 1, the graph is moving down slowly since the height is 0.2 meter, and because of this, the velocity is about to horizontal. So, the time are longer than test 2. Then for the test 2, the graph decrease rapidly and the velocity is slightly lower since the height is 0.3 meters and the time are shorter than test 1. Okay, number 8 is conclusion. In conclusion, Newton's second law of motion was proved in this lab based on the data obtained. Based on the graph, it can be determined that force is proportional to acceleration based on the curve of the graph increasing and decreasing as the mass attached to the force sensor was moved further and closer to the motion sensor. The values of this experiment were close. The theoretical value obtained which indicate little error was performed during the experiment. The data from experiment reveal that when an object is dropped from the same height would not affect the acceleration of the object because acceleration cannot change based on the height of the object.